Okay, so if everything is all right, then we should be streaming right now. Um, let's just make sure that, yeah, okay, we're live.
We're live.
Yeah,
Okay.
so, hi Ori. Nice to see you
my
again,
man.
my friend. Hi to everyone at
Yeah.
home or wherever you're at.
Another podcast.
Yeah, another program. We're doing a live show today. We hope to do this weekly. Up until now, we have some difficulties to do all the proper settings, but I think that today everything is all right as we wanted. And what do you wanted to talk about today?
Yeah, well, I think let's remind ourselves what we spoke about the other time.
Yeah, so the other time we talked about a little bit about data science. Remember, we talked about different kind of aspects of data science, the technology part, which includes programming, the statistics / math part, and business domain knowledge part.
The difference between data science and data analysis.
Yeah, right. We talked about that as well. So today we can talk a little bit more about that.
Yeah. I think it's a broad subject. It's something that we can, investigate for many hours.
Yeah.
And we know that a lot of people approach us and ask us questions about how do I get into the field, or I'm a data analyst, I want to become a data scientist. I'm an accountant for 10 years, I want to become a data analyst. We've heard it
Yeah.
all. So yeah, let's dive in and try to understand all
Yeah.
the differences and what kind of jobs, what actually happens. Okay, I've been doing the course of data science, data analysis, whatever, and what am I aiming for? What if I start a job? What's going to happen? How is everything going to look?
Yeah.
Yeah, I think that's super interesting.
Yeah. Sure.
Yeah.
The one of the main things that I see all the time is people always have these questions. I mean, no matter what they want to do, if they want to be an employee or they want to be an entrepreneur, they all have the same questions about how actually they can monetize data science in a way, in their way, no matter what it is. If it's a data analyst or data scientist, how do they make money and make living out of that? This is the main thing that I see all the time. So let's continue from last time. I mean, we talked about data analyst and about data scientist. There's another main job criteria which is called data engineer.
Yeah, something new. There's this kind of like the whole data engineering thing. It's something that popped up like 3 or 4 years ago, I think.
Yeah.
So we can think about it as some kind of an evolution of more like roles as we know of. We had BI, right?
Yeah.
We had BI.
Business intelligence.
Yeah, business intelligence. It's something that is very like traditional, and a lot of people are doing BI these days for many years.
Yeah.
And also we see students that come to us from BI and they want to do data science. They want to understand what's the difference between data engineering and data science.
Yeah.
So there's a thick line between them, but also the line could look very thin.
Yeah.
So we can try and explain, where does the line pass?
Yeah.
So generally, data engineering. Today we have a lot of data everywhere.
Yeah.
Everyone's been aggregating data for many years, and data science and data analytics. The goal of these fields is to make sense and get insights from all of this data. But there's the whole sometimes people speak about the iceberg, right? So the iceberg, most of an iceberg is under the water,
Yeah.
and you know, we see just a very small part of the
Yeah.
iceberg outside of the water. So we can think about data and insights from data similarly to an iceberg, and that's, you know, we see some of the insights, we see some part of it, and a lot of people are doing lots of work in those areas, and this is data science and data analysis, but still there's so much data that is hidden under the water,
Yeah.
and data engineering is something that had its growth from just aggregating and storing all of this data efficiently, and efficiently is the key, because if we store data, that's the easy part.
Yeah.
We can always add more storage,
Yeah.
but the thing is, if we want to access a certain part of the data, and we have so much, then storing it properly, then this is the general idea of data engineering. How do you get access to all of the data efficiently? If you want to do the data science and the analytics and build applications on the data, then you need to think, okay, how I'm going to solve it, and this is an engineering problem.
Yeah. Sure. So basically, the role of a data engineer, as a continuation of what you just said, has been developed through the years for not only storing the data, but also storing it in an efficient way, which is not only efficient in terms of the storage that it occupies, but in speed of collecting the data back and retrieve it and do data manipulation over it. So this is basically a huge challenge, especially in our days that we have lots of data, which is something that evolved tremendously in the last 10 or 15 years, I would say, ever since Google and Yahoo came to the world and started crawling the web and collecting data. So in terms of, okay, so data engineer, okay, we got that part. But another thing about the data engineer is that eventually he is like the assistant, if you will, of the data analyst or data scientist, in terms of he has to take the data and give it to the data scientist or to the data analyst for him to start doing his work. So he basically has to do a lot of processes that efficiently give access to the data for the data scientist or the data analyst so they can do everything that they need to do. So this is a huge requirement because there's a lot of technologies that have been developed, and the data engineer can find himself working with a technology such as Hadoop with Spark for a specific implementation like Hortonworks, which is basically wrapping up together a lot of has its own Hadoop ecosystem with specific technologies, and you have something like Cloudera, which has their own kind of technology ecosystem of Hadoop. So data engineer is like this beast, if you will, that can do use of lots of technology and knows lots of programming and can make really good processes that give the data to any consumer whatsoever. So this is huge. And what do you think is the difference between the data engineer as we know and as we defined now versus let's say a BI developer for the last couple of years?
Yeah. So actually, a lot of the people that we meet and that we work with on a daily basis, so most of them, you know, there are not many data engineers around,
Yeah.
because it's new.
Yeah.
As data scientists, we need data engineers, as you explained, because it makes our life much more easier, and a project without a data engineer can have bottlenecks.
Yeah.
And data engineering is amazing. BI, the main difference as I see it, BI developers, they do a lot of what data engineers actually doing, but they do it on like more classical architectures,
Yeah.
and more of like the things that most of the data of organizations today, as we know it, that the data that is used for many years, this is architectures that BI developers and DBAs, these are the people that created these architectures, and these architectures, they are the core of today's technologies for many years.
Yeah. You're
And-
talking about relational databases.
Yeah, because
Structured data.
because
things like that.
we need to understand that most data was relational and created relational
Yeah.
because it made sense
Yeah.
these days in the past, and as more data
Accumulated.
came and created, then new tools were needed,
Yeah.
and a data engineer is doing a lot of what the BI developers and DBAs were doing, but the data engineer is doing it on newer frameworks and tools,
Yeah.
and infrastructures and architectures, and so if you guys, people that are watching us right now, you are doing BI for years, and you are doing ETLs and moving data around for organizations, and SQL, and you've been doing all of these kinds of things, then for you guys to go into data engineering, which is today one of the most jobs with the
Wanted
highest paying jobs today in tech. There's high demand for data engineers. So you guys could, I believe, do the transition
Yeah.
pretty easily if you guys would like to learn new infrastructure, and not everybody would. Some people say, I'm good with what I'm doing now. I like the classical and relational databases,
Yeah.
and it's okay too, because we need those as
Yeah.
well. Data that is relational, it's data that, if it's relational at its core, then it should be stored relationally, and it will have the best performance this way. So that's cool. And if you're interested in seeing other types of data and how you can move that around and create very interesting architectures with the big data and the newer stuff, then as BI developers and DBAs, you could learn that.
Yeah, sure. I mean, even today, there's something which is kind of a mix between a data engineer and BI developer. I mean, there's technologies like BigQuery and Athena that basically enables you to write SQL and actually behind the scenes retrieve data which is not relational, which is crazy. I mean, you write something which is intended to retrieve data which is actually relational, but eventually the data is stored in a compressed way, and it's not even structured. It's keys and values and lists and all kinds of different data types.
And this is super interesting, because if I think about it now, then the only reason that you would use some kind of an API or a way to interact with such data, an API that would let you use it as it was relational, however, behind the scenes it is not. This is just because as humans, we are more familiar or maybe comfortable with the relational structure,
Yeah.
but there is no engineering real reason behind that. This is just for convenience.
Yeah.
Yeah.
Convenience and comfort.
Yeah.
And it works.
Yeah.
I mean, people use that because even if you collect huge amounts of data and you have a business owner in your organization that only needs a small portion of it, then it's a great way to retrieve exactly what you need from the whole data that you collected.
Yeah.
So it's pretty huge. I mean, everyone can use it. Even that specific person that we just mentioned and another data engineer or data scientist, they all can come around to the same data, which is stored in a technology, for example, like a data lake, which is basically like a place, quote unquote. Actually, it's servers that collects huge amounts of data, and the data could be from any kind of format, and everyone can use it. I mean, this is classical data engineering kind of work, and the man who will organize that eventually is the data engineer. I mean, this is a huge. I mean, even you and I had experience with data engineering. I think that now today one of the capabilities that a data scientist should have, at least in the beginning of his ways, not all the time, but at least some of it, a small proportion of it, should be data engineering, because he has to know what exactly does the data engineer work with, the problems that he experiences. So when they communicate with each other, and the data scientist will talk to the data engineer and ask for a specific thing, then he will know a better way to ask that thing, because he knows a little bit about the world of the data engineer.
Yeah.
And vice versa.
Yeah.
I mean, the data engineer, if he knows a little bit about the algorithms or how do they work or what do they need, so he knows the proper way to give the data to the data scientist or the data analyst, because he knows what the data scientist should do to use this data.
Mm-hmm.
I mean, there's a big congruency between all these fields, but this is huge. I mean, and all of these jobs, let's say, are actually spread around to new kind of jobs. I mean, you have something like a machine learning developer, or deep learning developer, which basically what do? They some of them actually take the algorithm, the statistic algorithm, and they don't care about the math behind it, for the math. They care about how can they implement the algorithm in the code to be as efficient as possible, to use as less resources and to work as fast as possible. I mean, they're not data scientists because they don't use algorithms to solve problems, and they're not actually data engineers because they don't collect data and give it to any consumer whatsoever. The sole purpose is to take the algorithm that the data scientist will use and to implement it. I mean, this is also a kind of a job that you see in the data science or AI community today. And this is also...
And we're going to see a lot more of new kinds of roles in the industry.
Yeah.
So I think that we can easily, because we know these things, like this is our profession and what we do on a daily basis, then it's very easy for us, to dive very deep into these subjects. But I know that we have also people that are watching us now, and people that approach us that they are less familiar with the industry, and they just want to understand who's against who and what's really happening. So I can think of if we want to explain to someone who is the data engineer, who is the data scientist, and who is the data analyst. You know, let's say that I am someone that is not in the industry. I want to understand even a direction. What should I look? I want to do an online course. You know, should I do the data engineering one? Should I do the data science one? Should I do the data analysis? Where do I start? So we've been getting a lot of these questions, and generally, I think that, and we last time on our previous live session, we spoke about the whole data science thing as an intersection of three areas. One area was very technical, and this is everything about coding and data structures, and this is usually the area of the data engineers.
Yeah.
We had another area which is more statistics, mathematics, algorithms, all of these science, and this is a lot of data science is there. And we had another area which is more like analytical, business thinking, data communication, more like the soft stuff. And we said that data science is the intersection of those three areas. And then we could think of like intersections of two areas. Like if we look at data communication and analytics and statistics and math, then this is usually data analysis. And if we look at all the algos and the tech stuff, this is usually data engineering. So if I would sit at home and don't know anything about this industry, and I would think, you know, where should I go? Then I would think about it like this. I would say, okay, if you're a person that is very technical and is very convenient with new technologies, and technologies are always evolving. You know, we've been hearing all the programmers, people that are programming for living. You know, when there's a new programming language, usually it replaces previous ones, and everything is evolving. So programmers need to live in a world where they are super proficient in some programming language, and after 5 years they need to learn another one.
Yeah.
For data engineering, you need to be convenient with evolving technologies.
Yeah.
You need to learn, you need to understand that, okay, now you are super familiar with one infrastructure and how it works, and you learned it very deeply, and then after 1 or 2 years there's something new that is a little better and is written totally differently, and you need to learn that. So you need to be very technical, very convenient with programming, computers, networks, servers, all of that. If this sounds interesting, then data engineering might be for you. Data science is, you need a little from each of those, but usually people have, they are strong in one more than the other. So I give an example. If I come from math, then I have some kind of an advantage in those areas, but if I studied mathematics at the university and I didn't learn a lot of programming, I need to learn that somehow, usually through a course or any other way. So data science, if you like, you're good with the technical stuff, but you don't want to dive super into that as a profession. You want to know how to use different architectures and use them efficiently, and maybe create some of those yourself. But also you like to get more insights from data and analyze it, and you're familiar or want to be familiar with statistics and mathematics and algorithms that try to learn from data. then data science could be more interesting. And for data analysis, if you say to yourself, okay, I like to analyze data, I like to see insights, I like to feel them, I like to feel the data and understand it, and create cool visualizations and statistics from the data. But I don't want to go super deeply into tech. I don't want to go super deeply into mathematical equations of algorithms and methods and all of that. Then data analysis could be for you.
Yeah, sounds good. So we hope that the whole kind of jobs, like the main ones, are much more familiar to you right now. So I hope you enjoyed this live, and see you on the next live, and have a good weekend.
Yeah. Thanks. Bye-bye.
Bye.